All right, let's continue from where we stopped. We have looked at the concept of inverse trigonometric functions. Now we've taken some examples. Let's take more examples, but this time we'll be taking application questions. Okay, now the first question says, if a right angle triangle has opposite side x and adjacent side 15, find the angle theta. The second question says, a ladder leaning a wall forms an angle of x degrees with the ground. If the ladder is 10 meters long and reaches the wall at height 5 meters, what is x? Okay, this is interesting. But before we proceed, let's remind ourselves of the basics that we will need. We're given that if sine x, let's say sine x is equals to a, okay, let's use a, then x will be arcsine of a. Similarly, if cos y is equals to b, then y will be the arc cos of b. And also if tan z is equals to c, then z is equals to arctan of c. All right, so let's apply that to this. Remember, in the previous video, we're using something like alpha, beta, and gamma. So, and this was x, and this was y, and this was z. Anyone? So far, you understand the concept of what we're driving at. So let's begin with the first lesson. First question. We have a right angle triangle. The opposite side is 8. The adjacent side is 15, and we are asked to evaluate what is angle theta. Now, the best thing to do when we have application question is to draw a diagram to depict the question so that we will have a graphical image of what we are working towards. Now we have a right angle triangle. The right angle triangle has angle theta, and in the question it says it has an opposite side of 8 and an adjacent side of 15. The hypotenuse was not given. Now we want to find angle theta. Now look at what we have. We have opposites, we have adjacent, and we have theta. Let's recall the expression of sine, cosine, and tan using SOHCAHTOA. Know that sine is equals to opposites over hypotenuse. We know that cos is equals to adjacent over hypotenuse, and tan is equals to opposites over adjacent. So very important. Now we have opposites, we have adjacent, and we have theta. Remember, this one has theta embedded in them. So definitely what we will be using is tan theta is equals to opposites over adjacent. So if we are using tan theta is equals to opposite over adjacent, we know definitely that our opposite is equals to 8, our adjacent is equals to 15, and we can evaluate our theta. So 8 divided by 15 using our calculator will give us 0.5333. Then we can use theta to give us arctan of the result, 533, and we will have our angle theta to be equals to 28.07 degrees. So we can see how simple it is to simplify an application question. The first thing to do is to draw a graphical representation, and the graphical representation will give us a guide on what we do. Now the next question says a ladder is leaning a wall. Let's duplicate this. Okay, duplicated, and let's solve together now. A ladder is leaning a wall and it forms an angle of x degrees with the ground. Now look at the description. We have a ladder, it is leaning against the wall. So let's have a wall, the wall, and then we have a ladder, it is leaning against the wall. So we can have a description of a ladder here. So if you have a ladder leaning against the wall, as the case may be, this is the ladder, and the ladder forms an angle with the ground of x degrees. Now we can say now the ladder is 10 meters long. The ladder is 10 meters long, which is the wall at the height of, so we're saying that from here to here is 5 meters. And what is the angle x? Of course, if it's a perpendicular wall, we'll have 90 degrees. So with this, we can just draw a simple diagram that depicts this. So all we just have is this is a right angle triangle with angle theta, with angle theta x degrees. We have 5 meters, which is the wall, and we have 10 meters, which is the ladder, and we are asked to evaluate x. You can say a ladder leaning against the wall forms an angle of x degrees with the ground. Okay, with the ground, and this is the ground here. If the ladder is 10 meters long and reaches the wall at height 5 meters, what is x? So this is the description we have, and this is the simplified expression. Now, if we are considering x degrees, definitely we have opposites to be equals to 5 meters, then our hypotenuse to be equals to 10 meters. So all we just have to do basically is just to find an expression that relates opposite over hypotenuse, and that we can do using SOHCAHTOA. We know that sine will be equals to opposite over hypotenuse, which is what we are looking for, something that relates opposite with hypotenuse. Okay, so using this expression now, we can say that sine theta is equals to opposite over hypotenuse. The opposite is equals to what? 5, or 5 meters as the case may be. The hypotenuse is equals to 10, and we are asked to evaluate sine. The theta in this case is equals to what? X, and we are asked to evaluate x. So simplifying this, we have sine x is equals to 1 over 2, which is equals to 0.5. Now this brings us back to inverse trigonometry. So with inverse trigonometry now, we can say that x is equals to arc sine, okay, or inverse sine of 0.5. So applying this, we have x to be equals to 30 degrees, because sine 30 degrees is equals to 1 over 2.